Come on in, come on in.
No, we started very hard.
No, this one is from previous class.
Oh.
So, what we are going to cover in the class today is going to be two folds. One is we'll talk about the angle relationships. There are a lot of interesting facts about angles.
Unwanted visitors.
Unwanted students.
Oh, yeah.
And that is all because of Mr. Marco and Vivan. They are supposed to be in the class on time so I can close the door and I can avoid unwanted students in the class. Okay.
Shall we just close it and I'll open it?
Okay, yeah, that would be nice. Alright, so we are going to talk about angle relationships and then
Top one or bottom?
top one. So like that. So we are going to talk about angle relationships and then surface area and volume of some common rectangular prisms and pyramids. And that is on special request from one of the kids. That's why we are doing that today. Likewise, for you guys also you have an option whenever you have any test coming up, something that needs you to prepare, you can let me know a day or two in advance and I'll cover those topics in the class as well. Okay? Otherwise, I have my own predefined flow that I follow. So, let's find out some interesting facts about angle relationship. I will try torturing you guys with some questions, okay? This is 35 degree. I want you to find out this. These are two parallel lines. I have find out this.
Isn't it the same?
No, think about it. Don't rush. So, everybody first pay attention or spend your energy figuring out, understanding what exactly it could be. Look at this one, this shape, this drawing that you see, I have a pair of parallel lines. This angle is 35 degree, you have to find out this angle. In this shape or drawing, this angle is 60 degree, this angle is 49 degree. I want you guys to find out how much this would be. Everybody give it a shot. Go wrong, be happy about it, that's fine.
180 degrees.
See, in my ear, how much? This one? This is 180? Okay. Greta, tell me.
Sir, for like the triangle.
This one?
49. Yeah, that one I got is 71.
This 71? How about this guy?
Yeah, but I haven't done that one yet.
Okay. Sidhu.
Do both of them have the same answer? No, right?
Obviously not. These are two different shapes. They have no relationship. They don't belong to the same family.
Okay.
Yep.
So for the first one, I got x equals 145
Okay.
degrees. And for the second one, I got x equals 71 degrees. 145, I just realized.
Okay.
I got it.
How about you, Anna? What did you get?
I got 71 degrees for the second figure, but I didn't do the first one.
Are you able to try it? Yeah, give it a try. How about Vivan? Yep.
Oh, wait. Mixed it up.
Okay. Vivan, Manas. Okay. Om joined now. So Om, I was trying to torture everybody while you were not there in the class. And these were the two questions with which I started my torture. I'm trying to find out what is the value of x here and what is the value of x here. Yes, Datta. Sorry, Suchit.
Sir, I got for the first one
75 for this one? Okay. Anahita, what did you get? You're talking to the mute button.
For the first, for the second figure, no, that one, I think I got either 71 or 73, I forgot, and then I'm still solving the first one.
Okay. Peter.
For the first one, I got 145, and for x, and then, I told you this is 71.
Okay. Yes, Anahita, what did you get?
I confirmed the second one, 71.
71. How about Aditri and Adya? Yes, Om. Go ahead.
What is the first answer?
I have some knowns and some unknowns. I have this as pair of parallel lines and this line is intersecting. This angle I know is 35. I'm trying to find out how much this would be.
Okay.
And this guy, I have two lines intersecting and making 90-degree angle, and on the other side of the line, this makes a triangle. I know this angle is 49. I want to find out how much this one will be.
Okay.
Yep. Adya. Sorry, Aditri. Okay. First one.
No, can I change my answer for the...
Sorry, one more time.
The first one I'm still working.
Okay. Yes, Suchit.
I meant to say 145 by the first one, so.
Okay. Now it's my turn. Everybody, whatever you guys did, it's wonderful. Some of you got right answer, some of you did not get right answer. I don't care about it. Now you'll say, what kind of stupid teacher is this who doesn't care about the answer? I don't really care about the answer, to be very honest with you guys. What I care about is, do I know the concept? Am I applying my concept right? Am I approaching in the right way? If these three elements are right, answer is just a byproduct. I would not want to worry about it. Manas, can you stop chatting? Trust me, I'm not going to entertain anybody to let chat. This is not a chat class. If somebody has to talk, unmute yourself and talk to me.
Sir, for my second one, my answer is 109. I forgot the last time.
Okay, so I seriously recommend everybody not to chat, not to engage into any conversation. If you have to talk to me, unmute yourself and talk to me. I'm ready for any kind of conversation as long as that is related to math. Okay? So, here, this one, the way, what I will do is, I will just run through this and I'll give you guys three magical traits. If you know those three traits, any angle relationship is going to be a cakewalk. I'll talk about that. So here in this case, this is 35, this will be 35, and in a little bit I'll tell you guys why. Because these are corresponding angles. These two add up to become 180, so this is 35, remaining has to be 145, that's the only way you can get these two together as 180. Okay? Now in this case, if this angle is 60 degree, this angle will be 60 degree, you don't have a choice. And these three angles will add up to become 180. So this is 60, this is 49, this has to be 71. 60 plus 40, 100, 109, this has to be 71. If this is 71, these two together will be 180. So if this is 71, it has to be 109 degrees only. Let's go step by step. This part clear? 100% clear? And let's go from here. Do I have a way to find out this angle real quick? No. I will go step by step. Let's figure out what we know. This angle and this angle has to be same because these two lines are meeting each other here. So your vertical angle or the opposite angle will be same always. That's something that you guys know. So this is 60. This has to be 60 only. Yep. Now, sum of the three sides, sum of the three angles of a triangle is nothing but 180. What you know is 60, what you know is 49, and what you don't know is what you don't know. Let's call this is y. This equals 180. Yeah. Now this y will be equal to 180 minus these two. Correct? These two add up to become 109. 109 plus y equal to 180.
Oh, I thought that was a 45. Okay.
Yeah. That is something about my writing better. I cannot change it now.
No, because I thought you said 45 too.
No,
so I got
no.
confused.
So this angle y is nothing but 180 minus 109.
Now I got it.
180. No, it's okay, better. My writing is not one of the best writings to come across. So this gives you 71. So this, if this angle is 71, then you know the magic to find out this angle. Yeah. Yep.
In all of these, whenever we get angle equations, can we assume that like the lines of the triangle, that those lines are straight?
So I mean, oh, this kind of drawing you're saying? The line
Yeah, can we assume that those are straight because like...
Okay, math is a subject. What?
I'll open it.
Whatever. Marco, try coming on time. I'm sorry?
I'm from here right after music class. Here back.
Okay. So because I'm doing this for you. Okay? Okay. Yeah, everyone, you're saying something.
Yeah, for the first one, I got 145 degrees.
Now that secret is disclosed.
Oh, God.
So, no, it's okay. See, it is not about me hearing the answer from each one of you. I wait for getting the answer from some of you guys and then I do it. And then I expect that you guys will, whoever was halfway through or close to being done, they can validate their answer against what I am doing. Okay? So that way we can efficiently use the time. Now, all that I was doing, that was more like a temperature check. I'm going to tell you guys there are only 3 key things. So everybody here, only 3 things. Okay, if I raise my both the fingers, that becomes 6. So I'll raise only one hand. There are only 3 key things that we need to know about when it comes to dealing with angle relationship. Okay? Marco, that's for you also. Only 3 things, okay? Keep in mind. Only three concepts that you have to keep with you. First concept, if I have 2 lines meeting each other, these angles, this one and this one, these are called opposite angles or vertical angles, whatever you like. They are same. And I will not try proving that. Yes, Kirita?
Wouldn't they be corresponding numbers?
No. No, so hold your horses, everybody. So I'll come to that time. I know what you are looking forward to and you will come across that. Just give me 10 minutes, you will come across it, okay? Everybody, okay, I'll not let anybody ask questions. Let me complete my story and then I'll give you guys a chance, okay? Yeah.
What are they called?
They are called opposite angles because they are opposite or vertical angles.
And they're the same.
They are same, exactly same. So whenever you see 2 lines crossing each other, or at that junction, these angles, opposite angles or vertical angles, they are same. Similarly, these 2 angles will also be the same. They are also called vertical or opposite angles. This is the first rule. Okay? Now, I will not talk about this. So this is a bonus. This was a straight line. You just join another line with this one. This angle and this angle is supplementary angle, add up to become 180. So I'm not talking about this. This is not my one among the 3 things that I was talking about. Second rule is, or second thing is about the parallel lines. If you have a pair of parallel lines and the third line intersects them, then why did you not answer the question, Manas? I have a habit of bothering everybody, teaching the same concept 5 times, 10 times, 20 times, till I retire or till you guys come out of high school. So be ready for the same torture over and over again. And the only way to avoid the torture is by answering the question right. So that gives you the confidence, okay, my kids know it all. Yes, Manas? So Manas, whatever you have to tell me, you have to tell me. Don't type. I hate typing. Yeah, go ahead. Who are you talking to, Manas? I cannot hear you. Okay, I cannot hear you, Manas. So, and I will not entertain typing anyways. So either you find a device where your microphone works, or come to the classroom. There is no question. You fix this laptop issue, Manas. Otherwise, this is not going to be effective for you and for the whole class. Okay, so coming back to this one. I had given 2 questions at the beginning of the class, and which everybody answered, and you did not answer, so that's what I was referring to. Anyways, come here. If I have a pair of parallel lines and the third line intersects them, these angles are called corresponding angles. So this one and this one are corresponding angles because they are on the same side of the intersecting line and both are above the parallel lines. Similarly, this one and this one are also corresponding angles because both are below the parallel lines and both are the same side of intersecting line. This one and this one are corresponding angles. Who wants to challenge the teacher? This one and this one are corresponding angles. They are not. This was your chance to challenge me. Yes, Om.
I was gonna challenge you, but I raised my hand.
Yeah.
You put my second slide.
Yeah, that's okay with that. So everybody, so I got the clue. So let me first stop this nonsense, Mr. Ear. This keeps buzzing in between to disturb the class. Okay. So here, so what I was repeating here, just to make sure that you guys get the concept right. This one and this one can be corresponding angle because both the angles are above this line, above the parallel lines on the same side of the intersecting line. So optically you have to be in agreement, yes.
Would they both also be the same angle? Like
Yeah,
same
so
angle?
I have not disclosed that secret yet. I'm just saying, let's first make sure our understanding of the corresponding angle is perfect. These two angles are also corresponding angles. Okay? And the catch here is all the corresponding angles are same. Meaning, if these two are corresponding angles, they'll be same. If these two are corresponding angles, they'll be same. If these two are corresponding angles, they'll be same. If these two are corresponding angles, they'll be same. Yep.
Yeah.
Why are they corresponding angles? What makes them corresponding angles?
Say it one more time.
What makes them corresponding angles?
They are on the same side of the intersecting line and they are both above or below. So they have something in common. Okay? I will say my behavior corresponds to another person. And I will say only when there's something similar, there's something relatable. So here we are saying these two are corresponding angles because both are above these are parallel lines. Both the angles you see are above the parallel lines and both are the same side of the intersecting line. Yep.
Wait, when you mean like same angle, do you mean like if one of the corresponding angles was 90?
Second has to be 90, no choice. Okay? This part is okay for everybody?
Yeah.
Now, Anay, Sidhu, Anahita, Suchit, everybody okay, right?
Yeah.
Kids who are not talking, they get me more worried. If kids are talking too much, that also gets me worried.
I understand it, sir.
Okay. Alright. So let me check. Okay. Fine. Now let's go to next flavor of parallel lines. If I have a pair of parallel lines, we saw this one corresponding angle, this one are corresponding angle, this one are corresponding angle, this one are corresponding angles, and they are same. If I say this is a 190 degree, I'm just making it up. You'll never have this angle being 190 degree. If this is 190 degree, this angle has to be 190 degree only. I mean, again, I'm making a big mistake here. 190 is not possible, but I'm saying for number's sake, if it is 190, it has to be 190. Yeah. Now, what are these angles called? Yes, we got.
Opposite interior angles?
Okay.
In corresponding?
No. What do you remember what is called?
Corresponding interior angles. Something with interior angles.
No. Anay, go for it.
Alternate exterior angles?
Okay. Greta.
Opposite interior angles?
Opposite interior angles actually. See, look at this. They are on the opposite side of the intersecting line and they are interior within these two parallel lines. That is how you relate to it. Opposite interior angles. Now if I am talking about this and this, there will be opposite exterior angles. Okay? But these are called opposite interior angles. So far we saw that, okay, what are the corresponding angles? And they are same. Pair of corresponding angles are same in case of parallel line. Now say, are kind of forcing you guys to believe that opposite interior angles are also same. Anybody wants to contest that? They are also same. If this is 70 degrees, this guy will also be 70 degrees.
But what if they're called again?
Opposite interior angles. Yes, we won.
Okay, so I was right. I was right.
You were right. Yeah. So I see. This is my dirty technique. I borrow information from all of you, and then I package that as my stuff. See. Okay. So, anyways, jokes apart. Coming back to this one, these are opposite interior angles, and they are same. If I ask you guys why, can anybody tell me why?
Just that. Because that 70 degree and that exterior angle that goes right across from it is also equal. So basically,
Come on my video and become my YouTube sensation
this
today.
angle, this angle, this angle, and this angle are all the same.
This one are opposite angles or vertical angles, so this will be 70, and this one are corresponding angles, they'll be same.
And
That means
this
this one
is also 70.
I don't want to go here now. See, simple. I'm trying to find out if these two angles are same or not, which are opposite interior angles. Now see, first thing, this one and this one are same because they are opposite angles, two lines meeting here. And this one are same because they are corresponding angles. That means this one will be same. Yeah? Greta?
Tell me why it's the same.
No, I mean, see, we will talk about it if it adds value. I'm just relating to it, okay? So, I'll give you guys enough chance. Don't worry about it. My can of worms have just opened. There's more coming your way. If this is A and this is B, so A and B are same. If this is C, so what you're seeing is A and B will be same because these two lines are meeting here, opposite angles. A is equal to B. And you're seeing that B and C are same because they are corresponding angles. So if A is equal to B and B is equal to C, can somebody stop us from saying A is also equal to C?
No.
No. If nobody is contesting, let's agree for it. Yeah. Adya, Aditri, Suchit, Sidhu, Manas. Is it making sense? So with respect to parallel lines, there are only these two things that you have to remember. That is, your corresponding angles are same and your opposite interior angles are same. Okay? Now comes the magical formula. If I ask you guys, what is sum of all the angles of a triangle?
180.
Okay. What is sum of all the angles of a quadrilateral? Quadrilateral. Quadrilateral meaning rectangle, square, parallelogram, trapezoid, kite, rhombus, and
90.
No, 360.
360. What is the sum of all the angles of a pentagon?
I don't know.
Um, 60. 360.
No, it cannot be.
90.
You already said for quadrilateral is 360. For pentagon it cannot be 360. Yes, you do. No?
90.
Um,
180.
540.
540. What is sum of all the angles of a hexagon? Huh? Heptagon, octagon, nanogon, decagon. You can just go on.
I didn't know there was that many gone.
So many gone. Here, yes, Om.
I'm left for a few seconds. What was the question?
I was saying, what is the sum of all the angles of a triangle? Everybody found it easy and said 180 degree. I said, okay, how about sum of all the angles of a quadrilateral? Everybody unanimously said it is 360 degree. I said, what is the sum of all the angles of a pentagon? And Sidhu said it's 540.
It is 540.
Yeah. So, yeah.
I think the sum of all the angles from quadrilateral is 360.
360 is fine. I was talking about pentagon. Pentagon has 5 sides, 5 angles. Sum of that will not be 360. Sidhu said 540, right, Sidhu?
Yeah.
Yeah. And then I was going on a rampage saying, okay, how about hexagon? How about heptagon? How about octagon? Nanogon, decagon. All that was not to flex my skills. What I was saying was, okay, Om has something to add. Go for it.
The sum of all the angles of a pentagon is 540 degrees.
So I will tell you guys. You guys are young. You guys have your brains working fine. You don't have any issue with your memory. I have. I struggle with memory since my childhood days. I have done horrible whenever it comes to decagon. Manas, if you get your audio thing fixed, trust me, we'll have a much more productive discussion. Let's not worry about that. Now pay attention to what I'm doing on the board. I'm saying don't worry about sum of all the angles of any shape. You will use one formula, 2n minus 4 into 90 degree, and that's it.
Wait, what?
2n minus 4 into 90 degree.
What is this? Wait.
N stands for number of sides in the shape.
Wait, it's an equation to solve
It's
everything.
So this is a magical formula which will tell you what will be the sum of all the angles in any polygon.
Magical equation. Oh, it works with triangles.
If I say triangle, that means the number of sides are 3. So 2 into 3 minus 4 into 90 degree. That
And
is
what does
the
y stand for?
This is not y, this is 4. My handwriting is horrible. Why you are relying on that?
I don't know. I'm writing it down.
I have to learn how to write 4 in a different way. Maybe like this. Better.
Sure, but just it is like a magical formula for any shape.
Any shape. Any legitimate shape. Yep.
Wait, why is it 4?
Is that an N or an 2N?
2n. 2n minus 4 into 90 degrees. N. N for the number.
I have a question.
Yep.
Why is it 4?
Don't even ask me. Magic don't have answer. These are just tricks. So let's see if this is relevant or not first. Okay? If I'm talking about three sides, triangle, I will put 3 in place of n. That became 2 into 3 minus 4 into 9. So now 2 times 3 is 6 minus 4. That gives me 2. And that multiplied by 90 gives you 180 degree.
Wait 1 second.
Okay? Now let's go to a quadrilateral or rectangle, whatever you want.
So we do. Okay. I think I got it.
Now we go to quadrilateral. How many sides it has? 4 sides.
Why is that so?
2 into 4 minus 4 times 90. See how much it became. 2 times 4 is 8, minus 4 is 4. 4 into 90. 360 degree. Now let's see whatever Sidhu said and whatever Om said. A pentagon. Sum of all the angles 540. Let's see if that is correct. 2 times 5. Pentagon has 5 sides. 2 times 5 minus 4 times 90. 2n minus 4. So n is your number of sides. Let's see what happened. 2 times 5 is 10 minus 4 gives you a 6.
Wait, we're doing that for a hectagon?
It can work for any gon.
No, but what are you doing now?
This is for pentagon. Pentagon. 5 sides. 6 into 90 gives you 540. I agree with what Sidhu said and what Om said. Yes, Vivan.
My mom is calling me for something. Can I leave the class?
Yep. Then you have only extra responsibility of watching the video of the class so that you don't miss it. Okay? Alright. Does it make sense to everybody or it's still in the thin air? Yep.
What is that like giant word say?
What is that?
What is that like huge word say?
Quadrilateral. Quadrilateral. So basically, so you have to know better. You have this video that you can watch always. I will get one extra view. Okay, but yeah, jokes apart. The fact is, this video is meant for you guys only. I don't have a lot of subscribers. Don't worry about it. This is only for you guys. So when you watch it, quadrilateral is a family of shapes which has 4 sides and 4 angles. So within that family, you have rectangle, you have square, you have rhombus, you have kite, you have parallelogram, and then you have trapezoid also.
Kite is a shape?
Yep, kite is a shape.
Wait, what is?
Kite is a shape.
Oh,
You would remember
Oh,
that.
it's a diamond.
yeah, diamond.
Diamond is different, that is rhombus.
Oh yeah, technical terms.
Yep. Is everybody with me so far? If somebody wakes you up at 5 o'clock in the morning and says, tell me the sum of all the angles which has 12 sides, you will say, I don't mind. 2 times 12 minus 4 into 90.
1,800.
2 times 12 is 24 minus 4 is 20 into 90 is
1,800.
That's it. Yep, makes sense? Just beat it.
Yeah.
Compared to the data, I don't know, but like
Okay. Yes, Manas, you are typing something. You have become a typewriter for me. Don't type that much. I want to talk. Tell me what is the question. I'm not here for chatting with anybody. Trust me, I don't have that ability to do so when I'm teaching you guys. You just tell me the number. Again, I will not respond to that. I will not even respond to that. I'm not doing anything unproductive in nature right now. I don't know everything. That's okay. You fix that problem. Otherwise, I don't have the ability to. I cannot fix that my problem, my honest. Let's stop typing. That doesn't work. Don't tell me that you don't have a device at home which doesn't have a microphone working.
Wait, sir, can I ask a quick question?
Yes, please.
So why exactly, so what is the sum of all of the angles from quadrilateral?
360. We just saw that. We put 4 in place of n. That gives me 2 times 4 is 8 minus 4. So what is the, I have inside the bracket. 8 minus 4 is 4. 4 times 90. That gives me 360.
Okay.
Yeah.
Wait, who cares? Why is it 4? I'm still confused.
So this is experimental formula.
Oh.
So what they did was they found ancient times, right? Ancient times somebody was grappling to figure out how do I generalize this? How do I give a method to the madness?
So what they did is they went 2 and
Now look at this. Look at the fun part of it. If I say what is the sum of all the angles for a shape which has only 2 sides? I cannot have a closed shape which has only 2 sides.
That's gonna
And if you want to still figure out, you put no, don't rush. If I'm talking about shape with 2 sides alone, what I'm talking about? 2 times 2 is 4,
Well,
minus
0.
4, 0 into 90 degrees. Have fun. Got it? Did you get it? Kian is still thinking, and I'll let you think.
I get it.
So see, the catch here is all this is math is derived based on a lot of experiment, mathematical calculation that was done by mathematicians in the old times. Yeah. So now you guys have one magical formula that you can brag about, and I will insist you guys please do that. Whenever you meet with your friends, catch hold of your friends, say, okay, you know what? Tell me how many, you know? So, tell me what is the sum of all the angles of a heptagon, which has 7 sides? And your friends will start scrambling about it. And you are not willing to flex your knowledge. You are doing to practice actually. When you show it to 2 of your friends, that becomes your concept. You don't have to even try memorizing it. Yeah. So I will keep on teaching you some dirty techniques to deal with it. So these are 3 things. If I kind of collate it and give us one message, what are the 3 rules that we learned or 3 techniques that we learned?
The opposite angles or vertical angles.
They are the same. When you have 2 lines meeting each other,
Yeah.
opposite angles and vertical angles are
The
same.
same thing. And then corresponding angles like this and then a dash like that.
When you have a pair of parallel lines and a third line intersecting both of them, your corresponding angles are same.
And then we have opposite interior angles which are
same.
2 parallel lines with third line
Opposite,
intersecting.
yeah.
And then but they're opposite but they're inside.
Yeah, same thing.
Yeah.
And the third thing we learned was this magical formula, which just tells you sum of all the angles of any shape. Yeah.
And a little bit of supplementary.
What is that?
A little bit of supplementary.
Little bit of?
Supplementary.
Yeah. So
No?
yeah, so that we did as a practice, right? So net, what we are saying is, if you have any shape, if you know the number of sides in the shape, if you have to find out sum of all the angles, you use this formula 2n minus 4 into 90. That's it.
Wait, I have a question. Does it work for all shapes?
Any shape where you can count the number of sides, and that shape has to be a closed shape.
What if it's closed, but there's no, you know what, never mind. For a circle, I
Okay,
get
don't-
360 sides.
Don't try to find out some of the angles of this shape.
How do you do a circle?
Circle doesn't have countable sides.
Oh, so it's like,
It doesn't apply to them.
you usually do like 360?
360 simple.
Oh, so basically just any polygons.
It's only for polygons where you can count the number of sides and it
2
has
and
to be-
minus 4 times 90 only applies for polygons.
Exactly. Do I have concurrence from everybody? Is everybody comfortable with whatever we have discussed so far?
I think.
Yeah. How about Adya, Ritri, Sidhu, Grihita, Anay, Om? Everybody okay? Yes, Manas, you have to say something. Without you saying something, there is no conversation. Manas, you get this audio thing, mic thing figured out, okay? Trust me. Otherwise, it's not going to help. Okay? Alright. So, let's go to the next topic. And I remember we had talked about that in one of the previous classes. Yep. Okay, now I can hear you. Did you understand what I said?
Well, I didn't see the questions, but not exactly. I know we learned opposite interior angles and corresponding angles, but what was the last thing we learned?
That was to find out sum of all the angles in any polygon. Okay?
Oh, so we learned polygons?
Yeah, we just talked about that, right? So any polygon, sum of all the angles of a polygon, you can use one magical formula called 2n minus 4 into 9, 90, and that will tell you sum of all the angles for any polygon, be it a triangle, be it a rectangle, be it a square, be it a pentagon, hexagon, heptagon, octagon, nonagon, decagon. That's what I remember.
Would it work for 3D objects?
Okay. So, no, it will not. We're talking about shapes. Yes,
It
Greta.
only works for polygons.
So instead of like, from the formula, like, my last 4 times 90. So would that 90 like spin into like
Degree.
a
It's a
right
degree.
angle or something?
I mean, you can have your own technique to memorize that. You can say 12 minus 4 into right angle or 12 minus 4 into 90, whatever will work for you. For me, it's just a formula. I look 90 is 90. Yep.
Do you know what 2 sides are called?
2 sides.
Yeah, like, you know,
Angle.
a
2 sides are angles. That's it. Nothing more than that.
oh no, what do you call like? Do you know what 2 sides called?
Let's not worry about it. Outside syllabus. We have a long way to go. Yes, Om.
It's mathematically impossible to have a 2-sided 2D shape
Yeah, that's what I'm saying. So that's why just
without it.
no.
Without some of it being curved.
Right, that's what I'm saying. So this formula applies only for closed shapes, that is one, and it has to be a polygon. With 2 sides, no matter how many hours you spend, you're not going to close it. And if you're not closing it, this formula doesn't hold true for this. Yep.
I'll take you.
Let's not get into a discussion that doesn't yield any result. I am not motivated to waste time. Alright?
It's because I'm learning somewhere in school, like,
Send me the question first. Send me the question, then I'll explain that, okay? Yes, Sachin.
Wait, but a closed shape is just considered a line, right?
No? Closed shape, yeah, closed shape where only lines. We are not talking about finding out angle of this shape. It has to be lines only.
Well, this is connected. What about like the one you just drew?
That's what I'm saying. So this one doesn't apply for this. Here you are not able to count the number of lines because this is a curved shape. Curved shape can be imagined as lot of straight lines combined together. You cannot count them. So it doesn't work. Okay. Let's move on to the next thing that we wanted to do. And that was finding out volume and surface area of prisms and pyramids. Volume and surface area of prism and pyramids.
Yeah, I like surface area.
How do you find it out?
Oh, surface area?
Let's first worry. Okay, we have only 15 minutes. I don't know how much we can cover in one class. So I would want to set the precedence here. And then today let's focus on volume. Volume. Finding out volume of 3D objects. Let me see how you guys are comfortable. Out of the 10 minutes I have, initial 5 minutes will be a teaser from my side to see who all knows what. And remaining 5 minutes I will use for setting the ground rule and explaining some of the basic constructs. So, and some of you, if you think that we have done it before and we are doing it again, treat that as a revision of what you know. Don't treat this as a waste of time.
Wait, we're finding the volume.
Oh, I have.
Hold it.
I don't know.
Hold it little bit.
Wait, how do you draw that?
Multiple shapes.
Okay, first of all, does anybody know what are these shapes called? What is this one called?
Rectangular prism.
Rectangular prism.
Cuboid.
Cylinder.
Okay, well I thought you just asked for that one.
One guy has 3 names? My thing,
That's your rectangular prism.
it's a rectangular prism or cuboid.
Yeah.
Okay? Marco with me?
Yeah.
This is rectangular prism or cuboid. Why? Because it is a rectangle. It was a rectangle and we added height to it. And that is called cuboid. So you can always look at this as a base as a rectangle and then you have added height to it. If I steal Havisha's notebook, you guys can see this is a real example of a cuboid. It was actually a rectangle before. Now she added so many pages to it, so it got height also. It's a perfect example of a cuboid. I know cuboids don't have wires, but still.
It's okay.
Yeah. Okay? Yes, oh, you're saying something.
I forgot to lower my hand.
Okay, that's okay. So, cuboid, you have rectangle, you add another rectangle, keep stacking it one after another, like you see the A4 sheets, the printing paper that you put in the printer cartridge, right? So, you have so many rectangles one after another, and that adds height to it, and that became a 3D object. Because when you had a rectangle, you had only length and width. Now what you did, you added height to it also. So length is one dimension, width is another dimension, height is third dimension. That's why this is called 3D objects. When you have anything with height, all of us, including me, including Anil, including Rita, including Havisha, Marco, everybody, all of us, we are 3D objects. We have 3 dimensions in our structure. Length, width and height. Yeah?
Length is.
I mean, which way? I'm just saying, one this way, one that way, and one this way. Yeah? Anahita was so very quiet. You were with me, right, Buddha? Yeah? Okay. That's where, when the kids talk a lot, I have problem. When kids don't talk at all, I have a problem. So many problems I have. Yes, Anahita. Go ahead, Buddha.
I understand it, but I'm just not talking that much.
That's okay. Okay, that's fine. As long as everybody can follow me, I'm happy that I'm doing my job right. Okay. So this is cuboid. You have a rectangle as a base. You added more rectangle of the same size on the top of it, like you do A4 sheets, and that became a cuboid. Similarly, cube. This is a cube where you have square as a base. You start same size square to a point where your height is same as the length of the side of the square. And this is called cube. Now you guys will think, then what is ice cube? You guys have heard about ice cube so many times.
It's stacked with water.
Don't go that direction. My point here is, ice cube also came from the same mathematical term cube, where it's made of ice, but it is in the cube shape. The most ideal ice cube will be a cube of a shape of ice, a piece of ice, which has same height, width and length. That is how it was envisioned in the early days. That ice cube is a piece of ice which is like a cube, meaning its length, width and height all have same value. Be it 1 centimeter, 1 inch, 1 meter, 1 mile, 1 yard, doesn't matter. Same length, width and height made of ice cube.
Oh, sir?
Yep.
You know how you said an ice cube is technically a cube?
Mm-hmm.
But when you were talking about ice cubes and how they're kind of one form of cubes, but isn't like how sometimes whenever you're driving a cube,
So that's where people have gone creative, and now you will see that you have molds where when you pour water into it, when the ice comes out of it, it looks like elephant. We'll not call it ice elephant, right? We still call it ice cube,
Ice
but it doesn't look like ice cube. But let's stick to the mathematical definition. Cube is nothing but a shape which has square as a base, and then there is a height where the height is same as the side of the square. Is that okay?
Yeah.
Yes.
Anahita, Adya, Aditri, Anay, all A's. Sidhu, everybody okay? Rita okay? Avisha okay? See? Alright. Now, then comes the right. This is called what?
Cylinder.
Cylinder. It's called right cylinder.
Oh, why is it right?
You don't call it cylinder, you call it right cylinder.
It's
Why?
like
Because
it has a
imagine, see how creative your teacher could be.
Yeah, that's the right cylinder.
This is also a cylinder, but not right. This one is right cylinder.
Oh, because it's
Curved
standing
cylinder.
up.
Because if you look at the center, if you join the center of the top circle,
It's gonna fall.
it doesn't make right angle with the base.
It's not
Like
perpendicular.
Here, if you look at the center, it is making right angle with the base.
a leaning tower. of Pisa.
Yep. Yes, Sidhu.
Can I go to the bathroom?
100%.
But wait. Never mind.
So, see, I don't think this is a mathematical or legitimate way of explaining it. But what I'm saying is, we all see that the cylinder standing straight is called right cylinder.
Wait, what would you call that one? The leaning tower pizza.
This is just a cylinder, I'll not call it right cylinder, that's it. This is just a cylinder, it looks like a
I
cylinder.
thought it would have like a different name, like 30.
Thankfully not. Otherwise, imagine how many more new words will come into your math vocabulary. Yeah.
180 cylinder.
Okay, Greta. You are talking to somebody, but I cannot hear you. Your microphone is not helping me. Yeah.
So, like for the right cylinder, would it be like same like as the other strings, but like it would be more like stacked up of a specific?
So here, right cylinder. This is a miniature of a right cylinder. Obviously, this is not even. If I cut the top portion and cut from here, whatever I'll be left with, that will be example of right cylinder. If you look at it from this side, what you're seeing is a circle. So right cylinder is made of circle as a base. If you have a circle, keep stacking another circle. Like this water bottle. I like mine. So when you see this as a cylinder, I mean this portion above this is not giving right picture. If you look at the base of it, it's nothing but a cylinder. I might end up taking bath in the class. So this base of a right cylinder is always a circle. So many circles start one after another, and that added height to it. So if you look at this one, cuboid or rectangular prism had a base of a rectangle and you added height. Cube had a base of a square, you added height. Only condition being your height is same as the side's length. Right cylinder had a base of a circle, you added height to it. Yep. Is it making sense? Don't write on the table. I have just cleaned it few days ago. You can see how clean that is.
I'm reading it.
Don't write, because I saw a lot of very bad things written on the table also.
Yeah.
So, very bad things. Don't tell me what. If I say that, people will start hating me. If I just read what was written. Okay. So here, leave it. I'll leave it. That's okay. That's fine. So now, if you go back to this one, you had a rectangle as a base. You added height to it. It became a cuboid or a rectangular prism. You had a square as a base. you added height to it, it became a cube. You had a circle, you added more circles on the top of it so that you got a height.
Wait, I have a question. If there's so many circles, shouldn't it also be like round? Oh, it is. Okay, not bad.
They are all same shape.
No.
Now, the catch here is when you are stacking it, these are symmetric shape. It is not like a swinging. Okay? It's not symmetric. It is not this way. It is like this. It's symmetric. Okay?
It's an S.
Yeah? So, all the shapes we are talking about, they are all symmetric. Meaning, whatever is the area at the base, that is the area at the top also. Now,
Wait, I have a question.
Hmm.
You know how it's a closed shape, the one that's with the squiggly lines? Can you find some of the angle for that one?
I have, oh, no time left.
Oh.
It's already 8 o'clock. So before I let you guys go, one thing I wanted to tell was that all these shapes that you have, these need space, right? I mean, you can see how thin or fat I am right now. If I add, let's say, 200 more pounds, I will need more space. That space is called volume. The space that any object takes in the space is called volume. Now look at my water bottle. This needs some space. Can I put this in my pants pocket? No. That doesn't have enough space to accommodate this much. So this needs certain space. Any object taking space is the volume. Now, if you're talking about this guy's volume, what you will do is, volume of all these shapes that we're talking about, that will be area of the base times height.
Wait, can
Yep.
I see what it is for the the cylinder?
So, yes, I think everybody is trying to wrap up the class.
Oh.
Okay? Yes, Adya, go ahead.
Couldn't you also do like times width times height?
Yeah, so see, I'm giving you guys a magical formula here. I'm saying that if you have a symmetric object, how do you find the volume of that? You will find out area of the base, multiply that by height. Because your volume is increasing due to the height. You had a rectangle, it was taking this much space only on the surface. You added more rectangles on the top of that, and it's taking more space. So find out area of the base and see how much height you have added to it. Multiply area of the base with the height. So in case of a rectangle, this one, area of the base is length times width, and then your height. Done. If you are talking about volume of a cube, here your area of the base is area of the square, which is length into length, and times the height. Your height is also same as the side, length cube.
Can I see the cylinder one?
Yeah. Area of this guy, volume of this guy
Can I see
is area of the base. Yeah, tell me how much will be.
pi radius cube times height. I think.
Pi r square times height.
Yeah.
Because the area of the base is area of the circle, which has a radius. Pi r square multiplied that by height. That will be your volume of the right cylinder. I just touched upon this core concept of finding volume, and then use the same core concept by looking at the area of this guy, area of the base of this guy, area of the base of this guy, multiply that by height. That's it. Yes, Sujit.
Sir,
Yep.
for the cube, couldn't you also say that it could be length cube?
Yes, it will be length cube. Length into length into length. Length cube. That's it. So do. Saying something? You're saying something, you raise your hand, that's why I'm asking.
Yeah, so the formula there, pi r squared height, is that for the circular or is that for like?
This is volume of the right cylinder. So what I'm saying is find out the area of the base, multiply that by height. Area of the base is going to be area of the circle, which is pi r square times height.
Sir, then would the circle's area formula be r
pi r squared.
That,
Yeah. Area of the circle is pi r squared, and we'll talk about that. So I just wanted to set the context how the volume is derived using the same concept. Remember one thing, as long as we are clear about the property, as long as we know the area of the base shapes, how the volume comes into picture, how you multiply height with the base area of the base, gets the deal sign for you guys. Yep. With that being said, I'll let you guys go. Talk to you guys again day after tomorrow and see how do we peel up the onions more. Yep. Bye bye. Have fun. Bye bye. Good night. Bye bye. Bye bye.